Welcome. This video is going to take a look at something called limiting reactants. And when you're doing stoichiometry, limiting reactants just throws another wrinkle in there. And again, if you truly understand chemistry rather than just do chemistry, then limiting reactants aren't that big a deal. So I'm going to try and walk you through it and make it as simple as I can. But the idea with limiting reactants is that unless you have a decomposition reaction, you're going to start out with more than one reactant. And it's going to be very rare that the reactants are present in the exact same ratio that they get used or consumed in the reaction. So that means one of the reactants is going to run out before the others, and it's going to stop the reaction. Okay, so think of it like an assembly line. You're putting together bicycles. You run out of seats, you're done making bicycles because people don't want a bicycle without a seat, or you run out of tires, whatever it is. So your other reactants will be left over, just like your other bicycle parts will still be there, but when you run out of one part or one reactant, you're done until somebody resupplies that reactant. So limiting reactant is defined as the reactant you run out of. It determines or limits how much product can form. Excess reactant is just what it sounds like. It's an excess. It's what you have left over. So most of the stoichiometry problems we've been doing so far have talked about you have so many grams of this reactant and an excess of the other one. So they've been telling you what the limiting reactant is. But that isn't always the case. So scientists often make sure one reactant, usually the cheap one or the safer one, is in large excess because it actually speeds up the reaction and it helps to make sure the reaction continues until all the limiting reactant is completely used up. So here's an example. If you have S8, so you've got sulfur combining with chlorine gas and forming disulfur dichloride. If you had 30 grams of sulfur and 100 grams of chlorine, which would be the limiting reactant? Now, the technique I'm going to show you is different than what your book shows you, but I think it's easier. But you can compare it to the book and decide for yourself. I have 30 grams of sulfur, 100 grams of chlorine. Now, of course, the temptation is for people to say, well, obviously I'm going to run out of sulfur first because I have less of it. But that would be an incorrect assumption because, remember, it's all about the particles. For starters, I only need one sulfur for every 4 chlorine. But even that, you can't look at the grams and know because 30 grams of sulfur, who knows how much that is? It depends on how much sulfur weighs. In fact, it's S8, so 30 grams probably isn't very much. 100 grams of chlorine, I have no idea how many actual molecules that is. So really what I have to do is the same thing we've been doing with stoichiometry. I have to change both of these to molar amounts. And then once I have the molar amounts, then I can do a comparison. So let me go ahead and start with changing my sulfur, and I'm just going to label this so we can keep track of who's who over here. So 30 grams of S8. If I convert that to moles, 8 moles, or 8 S8 is going to be pretty heavy. 256.56 is the molar mass of our sulfur. So that means 30 grams is only 0.1169 or 0.117 moles. And that's of S8. So how about Cl2? 100 grams sounds like a lot. Well, 1 mole of chlorine is 70.90 grams. So 100 divided by 70.9, 1.41, well, that's a lot more than the sulfur. But I still can't decide for sure. I can't stop now and say, oh yeah, for sure my sulfur is the limiting reactant. See, I told you we only had 30 grams. Of course it makes fewer moles. Well, in this case it did, but I still have to look at one more thing here. I have to look at how much product does it form. When you're making bicycles, you need twice as many tires as you do handlebars because you put 2 tires on the bike and only 1 set of handlebars. Same thing with this reaction. I only need 1 S8 to make 4 moles of S2Cl2. So if I set up my molar ratio here and look at how much product I get, S8 will form 4 times the 0.117. I can form 0.468 moles of S2Cl2 from my sulfur. If I do the same thing with my chlorine, I get 4 moles of S2Cl2 from 4 moles of chlorine. So now 1 over 1, I'm going to get 1.41 moles of S2Cl2 from my chlorine gas. So even though sulfur is still my limiting reactant, it doesn't always work out that way. So you have to be careful. In fact, we'll see that in some of our examples here, that you can't decide looking at just the grams, and you still can't decide even when you've converted them to moles. You can't make a correct assumption until you get to your moles of product. You have to actually figure out which one's going to make more product, or really what we want to know is which one makes less. Less is limiting. So how many moles of disulfur dichloride would form? Only 0.468 moles, because then I'm out of sulfur and the reaction stops. Okay, so here's an example for you to try. First thing you're going to need is a balanced equation. So I'm going to go ahead and pause and fill in my equation. I encourage you to write your equation first and then restart the broadcast, the video. Okay, so here's my balanced equation. It's going to be magnesium combining with oxygen, and the reason I knew that is because it's burning in the air, which is full of oxygen, but also nitrogen and some other things. But it tells me my product is magnesium oxide, so obviously the magnesium is combining with oxygen. So my balanced equation is 2Mg plus O2 yields 2MgO. I've written in the mass of each reactant that we have. And it simply asks how many grams of MgO will form. And this is going to be true with many of the problems that you see in your chemistry work. It doesn't specifically tell you find the limiting reactant. The assumption is that you would have to check each reactant to see which one's going to limit or produce less product. So I'm going to change my 48.6 grams of magnesium into moles and do the same thing with my oxygen and see which one can make more MgO. And as I proceed here, I would encourage you to pause and see if you can do this on your own before watching my solution. So 48.6 grams of magnesium would be 1 mole weighs 24.31 grams. So it's going to be right around 2 moles, 48.6 divided by 24.31, 1.999, so I'm going to go ahead and round it to 2.00 moles of Mg. And my 64 grams of oxygen, I know that 1 mole of O2 weighs 32.00, so this is going to be 4.00 moles of O2. And again, I can't make my final decision yet. I have to look at my molar ratios, and I see I can expect 2 moles of MgO from 2 moles of Mg, or 2 moles of MgO. But with my oxygen, I can expect 2 moles of MgO from every 1 mole of O2. So this is actually going to be 8 moles of product. So this forms less product, so Mg is going to be my limiting reactant, and I will only make the 2 moles. So now that I know I'm going to make 2 moles of MgO, let me go ahead and scroll this. So my MgO is going to be limited to the 2 moles. So as far as grams, I need to find my molar mass, which is going to be 40.31, 16 plus 24.31. And 2 moles of that is going to give me 80.62 grams of my product. Here's another one for you to try, and again, remember you're going to need a balanced equation, and even though they don't specifically say it, you need to determine which one's the limiting reactant so you can figure out how many grams of product you get. So pause and see what you can do on this. My balanced equation is going to be P4 combined with oxygen gas, which is always diatomic, O2. Tetraphosphorus means P4. Decoxide is O10. So this one actually balances quite easily. I just need a 5 here. And the P4 is balanced. So what mass of product in grams should form from 25 grams of phosphorus? Yeah, when you have these zeros here, it's up to you if you want to carry them along. They're really just to let you know how many significant digits you should be carrying over. So 3 is what I'm starting with. So now to find this out, I need to start out by taking my P4. I'm going to change it to moles, so 25 grams. I want moles. I have grams. I find P4 and see that phosphorus weighs 30.97. So P4 would weigh 123.88. So my 25 grams is 0.202 moles of P4. So how many moles of product would that make? Well, I get 1 mole of P4O10 from every 1 mole of P4. So it also will yield 0.202 moles of product. My O2, I have 50 grams, and 1 mole of O2 weighs 32 grams, since there's 2 oxygen in O2. So 50 divided by 32 is 1.56. So it appears I'm going to have more oxygen. Well, I do have more oxygen, and that maybe I'll make more product with this. But now when I set up my ratio, I see that I only get 1 mole of product, P4O10, from 5 moles of O2. So now when I take my 1.56 times 1 divided by 5, I get 0.3125. I shouldn't say only, but I get 0.3125. Or I'll round that to 0.3125.